Having two different answers for this one. I would accept B or C. It does go to the 10th, so we for sure know it's 26.4. Technically, you can do one digit estimation after that. So you probably could do another digit if you wanted to, but B or C would work for that one. I'm choosing B. Question number 2, what is h of 3? So if you plug in 3 right here, what do you get? 61.44 centimeters. And what is that? Height of ball. It's inches? All right, inches then. After 3 bounces. Could HN be 150?
No.
Why not?
Well, I mean, it could, but it wouldn't be very realistic because
Yeah.
the ball would bounce higher than it's over.
It's bouncing higher than it started. Unless it's like flubber. Suppose that doesn't make much sense. C, which ball loses its height more quickly, this one or a tennis ball? So this one or this one?
This ball. Wait.
I think this would be this ball
Yeah.
or tennis ball. Should be tennis ball. Because 5/9 of its height is less than 4/5. You could put them into decimals. This is 80% of its height. This is, I don't know, 56-ish% of its height. How many bounces would it take for the ball to bounce less than 12? 11. And that's just trial and error. Plug it into the exponent until you get less than 12. Question number 3. What do you think on that one? After its second bounce, so if you take 80 divided by 0.7, you get 114.3. So that is its first bounce. And you want to know the initial height, so you actually have to do that again. And you get about 163.3. That's the starting height. D. What do you think on the next one? 2 of them can be eliminated right away. B and C can. Because you don't know what it is starting at. We don't have x of 0. Right? We are looking for this number here. We know it has to be less than 79. You're welcome. Now you have to decide if it's linear or exponential. This would be linear, this would be an exponential. Are you adding 22 each time? You are not. If you check the division of it, you get 1.28, 1.23, 1.27. It is an exponential.
I have a question.
Yes.
So, it wouldn't be B or C because it's not 0.
Right, you don't know where it starts at. Our graph doesn't tell us where it starts at. Question number 5. Linear or exponential? Are you adding close to the same each time? You're adding 4, adding 5, adding 4. 10 times 4 is pretty close to 39. So I'm going to say linear. You're adding about 4 customers per employee. Question number 6, explain why the balance is a function. Because the account balance depends on the years. Write an equation. Function f with regards to time, or you could just put y equals. Starting with $1,000, It's growing by a factor of 4%, 1.04 per year. Question number 7, average rate of change. Remember, when you look at that, guys, we're looking at the top and the bottom numbers. So I'm taking 1720 minus 1534, and then I'm doing the same for the x values. So 186 divided by 6 is about 31 people per day. Is that a good measure?
No.
Are we gaining about 31 people a day? No, it goes up, it goes up, it goes down, it really falls off at the end. So no, it's terrible. Add some, lose some. It's definitely not adding 31 people a day, but on average it is. That's why you always look at the top and the bottom. We had one just like that on the warm-up yesterday, where I think you got 10.5 as an answer, and it was doubling. Well, you're not gaining 10 times the people each day. It was doubling. Question 8. How much does it cost for a letter that's 1.5 ounces? $1.15. B? $1.15. What is the range of values? So what is the cost, my Y values? Well, it looks like I could get $1.15. I could get $1.61. And I could get $2.08. Those are my 3 possibilities for my Y values.